Students, welcome to the Anjanadri Academy. In this video series, we will see how to solve the problems on resistivity. Before that, let us derive the relation between the resistivity and resistance of a conductor. Imagine that we are having an electrical wire of length L and its diameter is D D. We know that the area of cross section of any electrical wire A is equal to pi d square divided by 4. We have to don't take the area of the cylinder, that is A is equal to pi d L. We have to take the area of cross section, that is A is equal to pi d square by 4. It can be written as pi r square. A is equal to pi r square also you can write. We know that the resistance of a conductor is directly proportional to the length of the conductor. I am calling this as equation number 1. The resistance of a conductor, similarly, the resistance of a conductor is inversely proportional to the area of the cross section of the conductor. See, that is, if we increase the length of the conductor, resistance also increases. If we increase the area of cross section, then resistance decreases. If we decreases the area of cross section, then resistance increases. This is the meaning of these two equations. Adding 1 and 2, adding equation 1 and 2, we will get resistance of a conductor is proportional to length divided by area of cross section. If we remove this proportionality symbol, we will get R is equal to rho into L divided by A. That is, rho represents resistivity of a conductor. Therefore, rho I can write RA divided by L is the given equation. Needs to be proved. Hence, we need to remember this formula. And what is the SI unit of the resistivity? We know that the resistance is having a unit of ohm and area of cross section is meter square, that is meter into meter, and divided by length of the conductor is expressed in meter. This meter and this meter will get cancels, and the remaining unit is ohm-meter. Resistivity. Let us move for the main questions on the resistivity. Let us take the first problem. What is the first problem? A wire is 1 meter long. What he had given in the problem? A wire of length, how much he had given? 1 meter long, and diameter, how much he had given? 0.2 millimeter. So therefore radius is equal to how much? 0.1 millimeter. So this can be written as 0.1 into 10 to the power minus 3 meter. And it's the resistance capital R, how much he had given? 10 ohm. Calculate the resistivity. To find rho is equal to question mark. We know that formula solution is, we know that rho is equal to RA divided by L. So to find rho, we need to calculate area of cross section, that is pi r square. That can be written as 22 by 7 into R is how much? 0.1 into 0.1 into 10 to the power minus 3 bracket square. I am writing in this way. That is, how can I write 22 by 7? How can I write this 0.1? 1 divided by 10. How can I this 0.1? 1 divided by 10. It can be written as 10 to the power minus 6, minus 3 into 2. That is the law of exponents rule. 22 divided by 7 into 10 into 10, that is 10 square into 10 to the power minus 6. Therefore, 22 by 7 into 10 to the power minus 6, and when it 2 goes to the numerator, it becomes minus 2. That is minus 6 and minus 2, it becomes minus 8. This is the area of cross section in meter square. See, in order to find the resistivity, I have to use this formula. Rho is equal to, what is that? RA divided by L. What is R here? 10 ohm. And what is area of cross section? 22 by 7 into 10 to the power minus 8. And what is the formula? RA divided by L. What is the length of the conductor? 1. So therefore 22 into 10, that is 220 divided by 7 into 10 to the power minus 8. It can be cancelled as a 7 3s are 21, 1 remains 10, it becomes 7 1s are 7, 3 remains 7 4s are 28, 2 remains 7 2s are 31.48 into 10 to the power minus 8 ohm meter is the answer for the given question. Next question, let us move for the next question now. What will be the resistance of a metal wire? Given what he had given, length of the conductor he had given as a 2 meter, and area of cross section he had given 1.55 into 10 to the power minus 6 meter square, and resistivity also he had given 2.8 into 10 to the power minus 8 ohm meter. To find here, to find resistance of a conductor is equal to question mark. Formula, what is the formula we are having here? Rho is equal to Ra divided by L, or R is equal to rho L divided by E. Everything had given in the problem, just we need to substitute. What is the rho here? Rho he had given 2.8 into 10 to the power minus 8, and what is length he had given? 2 meter, whole divided by area of cross section, how much he had given? 1.55 into 10 to the power minus 6. Therefore what happens here? 2.8 into 2 is 5.6 divided by 1.55 into, see this 10 to the power minus 8 into 10 to the power, this minus 8 into 10 to the power plus 6. What happens here? 5.6 upon 1.55 into 10 to the power minus 2. See, when this 10 to the power minus 2 comes to the denominator, what happens? 5.6 whole divided by 1.55 into 10 to the power 2, that is 10 to the power 2. What happens here? 5.6 upon 1.55 into 100. See, it becomes how much? 5.6 upon 155. Therefore the answer becomes here, when you simplify this, you will get 0.036 ohm. That is, the resistance value is 0.063 ohm. Let us move for the next question. Calculate the resistance of a copper wire 1 kilometer length. Given length, how much I have given? 1 kilometer. So that is 1 into 1000, that is 1000 meter length he had given, and the diameter, how much he had given? 0.5 millimeter. It can be written as divided by 2. 0.5 divided by 2, that is the radius. How much it is? 0.25 millimeter, and it can be expressed in the 0.25 into 10 to the power minus 3 meter. If the resistivity of the copper wire is 1.7 into 10 to the power minus 8 ohm meter, what he is asking us to find? Resistance of a conductor is equal to question mark. Resistance of a conductor is equal to question mark. We know that the formula to be used, R is equal to rho into L divided by E. See, let us solve the problem now. What is the formula? R is equal to rho L divided by E. What is rho here? 1.7 into 10 to the power minus 8 rho. And what is length here? 1000 meter. And what is area of cross section he had given? It is not given, we need to find. Therefore area is equal to, what is the formula? Pi r square. Pi is how much? 22 by 7, and radius is how much? 0.25 into 0.22 into 10 to the power minus 3, 10 to the power minus 3 bracket square. It can be written as 22 by 7 into 0.25 can be written as 25 by 100, and this 0.25 can be written as 25 by 100, and this 10 to the power minus 3 into 10 to the power minus 2, it can be written as 10 to the power minus 6. When you multiply the numerator, it becomes 25, 25 is 625, 625, and it is multiplied by, when we multiply this 22 into 625, it becomes, in the numerator it becomes 13750 into 10 to the power minus 6 whole divided by 7 into, see this 10, 100 means 10 square, and this 100 means 10 square, that is 10 to the power 4. Therefore, area of the cross section, how much it is now? Area of the cross section is equal to 13750 whole divided by 7 into, and it goes to the numerator, it becomes minus 4, and therefore 10 to the power minus 10 meter square, that is the area of cross section is 10, this much. See, now I have to use this formula. Therefore, resistance of a conductor is 1.7 into 1000, that is 1700 into 10 to the power minus 8 whole divided by, what is the area of cross section? 13750 divided by 7, means it goes to the numerator and into 10 to the power minus 10. See this, what happens, this 0 and this 0 get cancelled. 7 into multiply 1, this is 7 0 the 7, 7 7 the 49, 7 1 the 7 plus 4, 1 1 the 90 divided by 13750, and it goes to the minus 8, and when it goes to the minus 10 to the numerator, what happens? 10 to the power plus 10, and this becomes 10 square. See, when we simplify this, we will get the answer 86.5 ohm is the answer. This is the answer for the given question. Let us move for the one more question now. Calculate the resistance of an aluminium cable of length L is equal to 10 kilometer he had given, that is 10 into 1000 meter, that is 10,000 meter he had given. It can be written as a 10 to the power 4 meter he had given, and its diameter he had given as a 2 millimeter. It can be written as 2 into 10 to the power minus 3 meter, because 1 millimeter is equal to 10 to the power minus 3 meter, and resistivity he had given 2.7 into 10 to the power minus 8 ohm-meter. This is the given data. See, now what he is asking us to find resistance of a conductor is equal to question mark. Solution. What is the solution here? Resistance of a conductor rho is equal to R is equal to rho L divided by area of cross section. What is rho here? 2.7 into 10 to the power minus 8 into length of the conductor is 10 to the power 4 meter, and area of cross section is how much it is? Area we need to find. Area is equal to pi r square, and what is the diameter? He had given 2 millimeter. Therefore, r is equal to how much? 1 millimeter. I am substituting the same value, 22 by 7 into 1 millimeter, that is 1 into 1 into 10 to the power minus 3 bracket square, minus 3 bracket square. It becomes 22 by 7 into 10 to the power minus 6 meter square. I am substituting the same value here, 22 by 7. 7 goes to the numerator, 7 goes to the numerator, and into 10 to the power minus 6. So this can be written as 2.7 into 2.7 into 7 whole divided by 22. So 10 to the power minus 6 goes to the numerator, it becomes 10 to the power plus 6 plus 6 plus 4 plus 10, and into 10 minus 8 it becomes 10 square. So this can be written as 7 7s are 49, 7 2s are 14, and this is 18.9 into 100 divided by 22. Say 100 divided by 22. So therefore it can be written as when you simplify this, we will get 85.9 ohm is the answer for the given question. Let us move for the next question now. Calculate the area of cross section of a conductor to find area of cross section of a conductor if its length is given. What he had given length of the conductor, he had given 1 meter, and resistance of the conductor he had given 23 ohm, and resistivity of the material of the wire is 1.84 into 10 to the power minus 6 ohm meter, and what he had given, this much only had given. And we know the formula for the resistivity of a conductor. We know the formula for the resistivity of a conductor formula. We know that rho is equal to RA divided by L. We need to calculate area, therefore rho into L divided by R. Let us find area of the cross section, that is rho L divided by R. What is rho here? 1.84 into 10 to the power minus 6, and what is length here? 1, and R is how much here? He had given 23. So when we simplify this, we will get 0.08 into 10 to the power minus 6 meter square. It can be written as 8 into 10 to the power minus 8 meter square. This is the area of cross section of a conductor. Let us move for the next question now. The resistance of a metal of length 1 meter. What he had given, length is equal to 1 meter and resistance is equal to 26 ohm, and if the diameter of the wire he had given 0.3 millimeter. So this can be written as 0.15 millimeter, that is the radius of the conductor. What will be the resistivity? Of the conductor? He is asking in the problem. See, we know that rho is equal to RA divided by L. See, therefore let us find area of cross section, that is pi r square. Pi is how much here? 22 by 7, and area of cross section, that is 0.15 into 0.15 into 10 to the power minus 3 bracket square. It can be written as 22 by 7 into 15 divided by 100 into 15 divided by 100 into 10 to the power minus 6. So when we do this simplification, we will get in the denominator 4950 divided by 7 into 10 to the power minus 10. It becomes minus 10, because 100 means 10 square, 100 means 10 square, 10 square plus into 10 square, that is 10 raised to the power 4, and it goes to the numerator, it becomes 10 to the power minus 10, and therefore what to find? Rho is equal to RA divided by L. What is the resistance of the conductor? He had given 26, and what is the area of cross section? He had given 4950 into 10 to the power minus 10 whole divided by 7, and what is the length of the conductor? He had given 1. So when we simplify this, we will get, so this one, when we cancel this, This one 7 7s are 49, 7.1. So when we simplify this, we will get 18384.6 into 10 to the power minus 10. See this one, when we simplify further, 1.3846 into 10 to the power minus 6 ohm-meter, minus 6 ohm-meter is the answer for the given question. Is the answer for the given question. Let us move for the next question. A piece of 24, a piece of wire of resistance 20 ohm, given what he had given 20 ohm, that is the resistance he had given 20 ohm, is drawn so that its length is increased 2 times its original length. And new original length is L, new length L dash, and this L dash is equal to 2 times length. If the original length is L, and if the original diameter is D, and if the original area of cross section is A, then the new cross sectional area, that is A dash, is equal to A by 2. See, because this is the length of the conductor. See, this is L. If we stretch it, the length, what happens here? L dash is equal to 2 times L. Volume remains the same. Volume is equal to constant. Therefore, area, what happens? It reduces to the half. See, by looking into this, what can I write? The resistance of a conductor is proportional to length divided by area of cross section. Similarly, what I can write? R dash is equal to L dash divided by A dash. Therefore, L dash means how much? 2L. A dash means how much? A divided by 2. That is R dash. Therefore, R dash is equal to 2 goes to the numerator. That is R dash is equal to 4 into L divided by A. See, R dash is equal to 4 into, what is L by A? What is L by A? L by A means what? R. See, therefore, new resistance R dash is 4 times original resistance 20. Therefore, R dash is equal to 80 ohm is the answer for the given question. 80 ohm for the given question. Let us move for the next question. How does the resistance of a wire change when its length is tripled? And the length is tripled. We know that the resistance of a conductor is directly proportional to the length of the conductor. When length is tripled, then resistance of a conductor is also tripled. Similarly, second question, what is the second question? Its diameter is D dash is tripled, 3D is tripled. We know that resistance of a conductor is inversely proportional to area of cross section. Therefore, resistance of a conductor, can I write it as pi d square divided by 4. See, resistance, how it is related to diameter? It is related inversely to the square of the diameter. See, what is asking in the problem? R dash is inversely proportional to D dash square. See, R dash is proportional to D dash means how much here? 3D bracket square. R dash is proportional to 3 square means how much? 9D square. Therefore, R dash can be written as 1 upon 9 into 1 upon D square. See, what I can write here? R dash is equal to 1 upon 9, proportional to 1 upon 9 into R, means new resistance is proportional to the original resistance divided by 9 is the answer for the given question. We have to remember in this way, when the diameter is tripled, we have to take the square of that in the denominator of the original resistance. But it given one more formula. Its material is changed to one whose resistivity is 3 times. We know that resistance of a conductor is equal to rho L divided by area of cross section. If rho dash he had given 3 times original resistivity, therefore R dash is equal to rho dash L divided by area of cross section. Rho dash means how much? 3 rho L divided by A. So what is rho L divided by A? Rho L divided by A is what? 3R. 3R. This is the new resistance is 3 times the original resistance. 3 times the original resistance. Let us go for the next question now. The electrical resistivities of 4 materials A, B, C and D are given below. Which of the material is a good conductor? The material which is good conductor is having poor resistivity. See, which is having poor resistivity among A, B, C, D. See here, C option. Answer is what? Answer is C, because it is having least resistivity, and which can be considered as an resistor, and which can be considered as an insulator, and which can be considered as a semiconductor. Let us consider insulator first. Insulator means what? Which does not allow the current to pass through it at all, means which is having the highest resistivity. We have to take option B. Option B. Answer is option B. And which is used as a semiconductor. Answer semiconductor we can use. Now semiconductor D option ಆಗಿ ಕೂಡ ಯೂಸ್ ಮಾಡಬಹುದು. Answer D is the answer for the next question. That is, now remaining one is the resistor. Obviously, what is that? That is 110 into 10 to the power minus 8, which is equal to option A is the correct answer. Option A is the correct answer. Let us go for the next question now. The electrical resistivities of 3 modules P, Q and R given below. P is this, Q is like this and R is like this. Which of the following will you use for making the electrical wires? The electrical wires are the one which can be used, which are having very least electrical resistivity. The answer is among these 3, which is having the least resistivity, option Q. Answer is option Q. Similarly, handle for soldering the gun, which material can be used as soldering for the handle for the soldering of the iron? The option is answer R. The option is answer R. Solar cells, give for your answer. Solar cell means what? Which produces more heat. Therefore, the answer is option B is the correct answer. Option B is the correct answer. So by doing this, we completed the problems on the resistivity. If you are having any doubts, please do comment in the comment section. So thank you and have a nice day.